So in the last chapter, we were talking about graphing polynomials, and we had to factor them and find their zeros and do all those things to graph them. In this chapter, we're graphing rational functions. So a rational function is basically a fraction. In this, P and Q are polynomials. And Q can't be 0. We know in a fraction you can't divide by 0. So rational function just means the division of polynomials. The first thing we're going to talk about today is the domain of these, because your domain does actually change some things with your graph. We know domain is the possible values for x. So if I'm asking for the domain, in a fraction, what's the only thing we have to worry about? What we just wrote up there. The bottom can't be 0. So your domain, the things x can be, is everything except the numbers that make the bottom 0. And those are going to be the places where our graph does funny things. The majority of what I'm talking about today is finding the domain of a rational function. And all we do is look at the denominator. You do not need to reduce the fraction first. It doesn't have to be in lowest terms, because the graph is slightly different if it's reduced versus not reduced. So we don't have to do anything except figure out when the bottom is 0. So let's find the domain of each of these. The first one, if I said 2x squared minus 4 over x plus 5, the only thing we care about is the denominator. And in a rational function, the denominator cannot be 0, which means x cannot be negative 5. Now your domain is telling me what x is, so if it's not negative 5, it's everything else. How do we write that? Two with a parenthesis, union. So that tells me this graph exists everywhere except at negative 5. If I look at B, 1 over x squared minus 4, all we care about is the denominator. So x squared minus 4 can't be 0. That means x squared can't be 4. If I add a square root, what else do we need? So x can't be positive or negative 2. Now, my domain. In the past, I told you that if it was more than one value, x couldn't be, I would allow you to list them. So I would accept that answer on this one, but on part A, I would require the interval. If you wanted to do the interval here, it's everything smaller than negative 2, so negative infinity to negative 2. Union, everything between negative 2 and 2. Union, everything bigger than 2. So my expectation, if it's just one value, you must give me interval notation. If it's more than one value, you are allowed to list what x can't be. But make sure you're telling me x cannot equal, instead of saying x is equal to 2 and negative 2. Right. So look at C. So in a fraction, bottom can't be 0, so x squared can't be negative 1. Square root plus and minus, so x cannot equal plus and minus what? I. Okay, my domain, I'm worried about real numbers because I'm going to graph it. Do I have to graph I? No, so what's my domain? It can be any number. My domain is referring to real numbers only. D. My denominator is 3. So 3 cannot equal 0. Can 3 equal 0? No, so what's my domain? Okay, I want you guys to do E. So the bottom can't be 0. X minus 1 cannot equal 0, so x cannot equal 1. So your domain is everything else. Make sure on your interval notation it's obvious that you have a parenthesis on your 1. You don't want it to look like a bracket because brackets mean equal to. Now just as a side note, what if I had factored and reduced on this? How does x squared minus 1 factor? If I had factored that, what would happen with my x minus 1s? I just get x plus 1. Is this one a fraction? No, so what would be the domain of x plus 1? It's saying, what numbers can we plug in for x? I'm not dividing, so I don't have to worry about anything. What number can you add 1 to? So, even though we've always factored and reduced, if we look at the domains, are those two things equivalent? No. Domain is always based off the original, not what it reduces to. Okay, so always look at the original first. Any questions there? All right, when we draw these graphs, we are going to see what are called asymptotes. Asymptotes are lines that our graph is approaching without actually touching. We usually draw them as a dashed line. There's 3 types, horizontal, vertical, and oblique. It is possible to touch a horizontal or an oblique asymptote, like in the middle, but you will never cross over a vertical asymptote. We will be talking a lot about asymptotes in the next. All right, I want to first talk about one specific function so we can kind of see how some of these asymptotes happen. All right, if I ask you to graph what's called the reciprocal function, that is 1 over x. Anytime we don't know how to graph something, what do we do?
Look it up.
Oh, XYT chart. Thank you. Tucker gets an A for the day. Zach, you failed. Come on. Look it up.
Use my resources.
That's your brain. That's your resource. So if I put in a 1, 1 over 1 is 1. Okay, if I put in a 2, 1 over 2 is a half. 1 over 2 is 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 1 over If I put in a 3, 1 over 3 is a third. What's happening to this? It's getting smaller, and it's going to keep getting smaller, right? Will it ever equal 0? Can you do 1 divided by something and get 0 for an answer? No. So it's getting smaller, but it's not actually ever equal to 0. It's just approaching it. What if I put in like 1/2? What's 1 divided by 1/2? Think flip and multiply. So 1 times 2 over 1. So we get 2. So 1/2 gives me 2. So what do you think if I put in 1/3, what would I get out? 3. What's happening this way? It's growing. Now, can I put in 0? Can I do 1 divided by 0? We can't divide by 0. So what's happening is this is going up, and I can put in smaller and smaller things, but I can't put in 0. So we're getting this curve that's between the x and y axis. Now we could put in negatives as well. If you put in -1, what's 1 divided by -1? If I put in -2, I put in -3, it'd be -1/3. So same thing, it's getting closer, but it's not going to equal 0. If I put in -1/2, what would I get out? -2. If I put in -1/3, I get out -3. So this is going the opposite way. So this is what's called the reciprocal function. And what we can see is there's an imaginary line here and here that we are getting closer to, but we'll never actually hit those lines. Those are the asymptotes of this graph. My domain. What was the only number we can't plug in for x? 0. So -infinity to 0, union 0 to infinity. My range is my y's. I got out positive y values. I got it negative y values. What's the only y value we didn't get? 0. Vertical asymptote. This is a line, so we have to write it as an equation. Vertical is x equals. What's the vertical line we got close to but we didn't touch? This line is just x equals 0. Lots of zeros here. My horizontal asymptote. Horizontal is y equals. What's the horizontal line we didn't touch? Last question. Even or odd? I wanted to throw this in just because we haven't talked about it in a while. Remember, even means it's symmetric to the y-axis. If I fold this thing over the y-axis, does it overlap itself? No. Odd is symmetric to the origin. If I fold this over the y and then over the x, does it overlap itself? Yeah. So this is an odd function. I want to give you a graph and see if you can answer some questions by looking at it. Domain and range. Domain is referring to my x values. Range is referring to my y. Okay, I don't have any lines drawn in. My x's, it's coming from negative infinity if I go from left to right. Where does it appear to stop? 2. If I draw in, could draw in my dashed line here so we can see it's getting closer to 2 but doesn't hit it. So my domain is negative infinity to 2, union 2 to infinity. My range, if I go from bottom to top, it's coming from negative infinity. Where does it stop? which my y's break at 1. Then it picks back up after 1 and goes to infinity. My intercepts. X-intercept means where does it hit the x-axis? At 1, or if you want to do an ordered pair, 1, 0. Y-intercept, where does this appear to hit the y-axis? So my x is 0, my y is 1, 0, 1. What is the equation of my horizontal asymptote? What's the equation of a horizontal line look like, first of all? Horizontal. Okay, so the asymptote, the line we're approaching but not touching, is at y equals 1. Notice, my horizontal asymptote was at 1. That was the value that wasn't included in my range. Okay, my vertical asymptote, x equals 2. Notice 2 was the number not included in my domain. So when we're doing those domains, those numbers that x can't equal, that's where we're going to get those horizontal or those vertical asymptotes on our graphs. Oblique. An oblique is just any other line, so like a slanted line. Do we have any slanted lines we're approaching but not touching here? No, so there is none. So if I said y equals 1 over x plus 1. We could use transformations, couldn't we? We just graphed 1 over x a minute ago. What does a plus 1 do? So 1 over x it's like 1, 1, 2, 1 half, 1 half, 2. And the same, the negatives, -1, -1, -2, -1 half, -1 half, -2. If I move all of these points left 1, the original graph had a vertical asymptote at 0. If you move left 1, where's your vertical asymptote now? -1. Does that match up with the equation? Is -1 the value we can't plug in for x? Yeah. Okay, so we can track that. If we move each of these points then. Back 1. Did my horizontal asymptote move? No, it's still at 0. What would cause that to move? The vertical moves if we go left or right, so what would make the horizontal move? Up and down. So my domain, we said, was everything except -1. And that meant we had a vertical asymptote at -1. My range was everything except 0. And that's because we have a horizontal asymptote at 0. But if we moved our graph up or down, that could move our horizontal asymptote. Do you guys have any questions right now? And that's my stopping point for today. So there is a handout posted on Classroom. There's 10 questions with finding the domain, and then like 3 questions looking at a graph and writing your asymptote.